Alright, so if you guys can look at the warm-up questions, the first two are asking you to switch to log form. The last one's asking you to factor. So kind of feels like probably two really different things asking you there, and they kind of are, and they go together today. Is there weird like whistling right now, or is that just my
I think you
No,
should
I-
go outside and
That's
investigate.
just you.
Alright, so those first couple days, I want you to rewrite it in log form, just reminding you guys how to do that. After the weekend, you might not recall anymore. And then see if you guys remember how to factor something like letter C. If you don't, that's why we're here to talk about it, but we're going to use that a little bit today in some of the stuff we're doing.
I didn't realize you used the Mickey Mouse thing.
I know, see, I was trying to be all like theme.
Yeah. Pencils right here. I didn't even.
Do you see I had two shoes on today, guys?
Oh my goodness.
Wait, why aren't you wearing your costume?
I was tired of my like.
Can I wear it?
Yeah.
Should I take it to the 4Kers?
You could. They would like it, I bet.
Yeah,
You'd be like
they're
a
usually
celebrity.
nighttime.
Wait, what?
I should go. I want to go to
Yeah, the same time.
Yeah. No, they were very excited about it. It's kind of.
They do have us kindergarten.
Oh yeah, yeah. No, this is probably like their favorite day ever.
Or something.
Yeah, and all three of them are in Elsa dresses too.
Oh, that's so cute. Yeah, and that's, yeah. You should have got a picture with them.
I was scared. How many kids
Like I said, they were all over me. They were real handsy. Okay, guys. So, being able to switch to logarithm. What's my base going to be? What's the little number going to be in this case? The x. So the base stays the same. It's just like, so the base when you're talking about exponents is the big number, but the base when you talk about logarithms is the number that's kind of down below. So making sure you make that clear that it's kind of down below the logarithm or make it a little smaller. Log base x of what? Of y is going to equal whatever base is left over, which is going to equal the exponent. So like whatever the exponent is always what's going to equal. Just getting comfortable with making that conversion or that translation. So that's new to those of you guys who are gone, or like it's new to us as of Friday. It's understandable if this is a little bit of a struggle. This next one. So again, our base is the same. The base stays the same, but now it becomes a little one. And we take the log of what this equals, and that'll equal x. So being able to make that conversion. All right. Do you remember factoring ones like this?
Yes.
No.
It's like parentheses.
Yeah, it's like the double parenthesis. Because I know that so this is kind of reverse FOIL. I know I want to get x squared in my first two terms, so what is it going to start off as? X. So both of them are going to be x's. And there's like a little shortcut, a way to remember this. There's kind of like a pattern that always happens with this, that we want to multiply to get one in the numbers and add to get to the other. Does that sound familiar now?
Yeah.
We want to multiply to which one?
Middle.
16.
Very good. Holy cow, he's a factoring master there.
It's the only thing I remember.
So we want to multiply to negative 16. We want to add to negative 6. So what multiplies to negative 16 but adds to negative 6? Negative 8, positive 2. And that's the combination that would give me this outcome. And we are going to use that a little bit later on today. It's factoring problems similar to that one that you could be comfortable with. So hopefully that will kind of come back to you if it hasn't already. All right, so we're going to learn some laws about logarithms today that just are kind of like properties, just like when we're talking about exponents and I say, oh, we're going to add the exponents here, or we're going to subtract the exponents here. Same thing happens with these laws of logarithms. And where this kind of comes from is from the exponent rule. So over here, I'm going to kind of write a little shortcut. So if I have x to the a power times x to the b, what am I going to do with the exponents? Do you guys remember? You're going to add the exponents. Even though we're multiplying the bases together, we're going to add the exponents. That same thing happens with logarithms. Rather than multiplying these, what we can do is we can break this up as two separate logarithms, but it's going to change to addition. So this is going to become log base b of u plus log base b of v. That should be a v and that should be a u. So just like we have rules for exponents, we have rules for logarithms, and they have a very close connection. So that's not meant to be like a coincidence there. So multiplication becomes addition, just like multiplication became addition here. So now we have division. Any thoughts? Yeah. When I'm dividing, that turns into subtraction. We're going to subtract the exponents. So I'm going to break this up as two separate logarithms. But subtraction. Now this is not going to seem useful at all right now. Like it's going to seem like, why in the world are we doing this? This isn't helpful at all. It ends up being nice if we have certain types of numbers that putting them together or taking them apart would make them easier to work with. So sometimes we're going to go from the left to the right, sometimes we'll go from right to left, depending on the situation. This last one is kind of that product of powers. So if you guys remember, if I have like a, or x to the a power and then to the b, we multiply the exponents. It's hard to read. We multiply. So what we're doing instead here is this exponent. This is kind of the one weird one that I have a hard time kind of getting people always to remember or wrap their mind around, is that's going to drop down in front and become multiplication. So it's like this drops down in front. Or like I said, it can go the other way. And that should be an S and not a 5. It could be a 5, I guess, but in this case it's S. So that's taking me over to number 34. And let me see if I can. So number 34, this is where an example like this applies. Is right now, I don't really know what to do with this because 9 to the log base 3 of 20, we remember we want those to match. So we rewrote 9 as 3 to the second. Now when I have 2 times the log base 3, what I can do is raise this up as a power instead. So this time I'm going from this way back. So this is going to become 3 log base 3 of 20 to the second power. Now why this is so good is because 3 log base 3 cancels, and we're just left with 20 to the second, which is 400, which is what the answer was on the homework. So sometimes working one way or the other is going to be helpful here for these. So that's just a quick, like, why we didn't do 34 last time. Obviously, we didn't know how to do that yet. But we'll do some more work with moving things back and forth. To be honest, I don't know that we'll use I mean, these properties don't come up all the time, but we're using them from time to time, so I don't want you to not to be afraid to use them, I guess. So they want us to rewrite these using the law of logarithms. So in this case, if you look at this, it's not written, but we assume there's multiplication here. So we assume x is being multiplied by y. Which part of this is getting the second power? Just the y has the second power. So that's important to note, that I can't just take that 2 and drop it down in front right now, because the second power is only on the y. So what we're going to do first is we're going to break it up first. So multiplication is going to become addition. So I'm going to break it up as 2 separate logarithms. Oops, log base. And it stays as the same base. So I'm breaking that up as 2 separate logarithms. And again, they want us to use logarithms just to rewrite it another way. So that's one way we could write it. Probably the way we could change it the most is now this power can the power can become multiplication. So that power is going to drop down, but it's going to drop down only in front of this logarithm, because that's the only part it was on. So it's going to be like 2 times the log base b of y. So these two are essentially interchangeable. So I could go from the bottom to the top, top to the bottom. They should rewrite and be the same thing each of these times. And again, right now this is just going to seem like busy work. It's till we get more comfortable that we can use it a little bit more. Now division becomes subtraction. So we're going to break this up as subtraction now. Notice the second power is just on the x this time. Probably the most common mistake I see is students that don't write the log more than once. So when we break it up as 2 separate log, like the subtraction has to become 2 separate logarithms. And that base could be anything that stays the same though. And then again, we can just drop that 2 down in front. All right, I'm going to give you guys a challenge here. Look at letter C. See if you guys can get it started. And if you need to stop and not keep going, it's okay. That one is a little bit heftier, a little tougher. Kind of doing a bunch of things there. I'm going to take attendance, but. Alright. So what'd you break up first? Yeah. Did you make it into what first?
I broke up the.
Division, right? Yeah. So we're gonna break up the division first. Because I don't wanna break up like the 2 times w to the 4th because that's all in the bottom. So I would break this up first. Now one of the things I would suggest is maybe using parentheses with your logs in this case just to make sure kind of all the signs stay as is. So we're gonna break this up as minus okay, so we broke it up as subtraction. Alright, what do you guys want to do next? There's a couple of different things we can do. The exponent. So you're going to drop the exponent down in front here, right? Can we drop the exponent down in front here? Not yet. We want to wait on that. The reason for that is because that 4 is only on the w, so kind of trying to make sure you differentiate between that. So I'm going to write minus, and I think now I'm going to break up this multiplication, if that's okay. So that's multiplying, so I'm going to break that up. And I'm using parentheses just to make sure all my signs stay kind of the way they're supposed to. And this is multiplication, so it's breaking up as addition. And we want to get rid of that exponent, so where's that 4 going to go? In front of where? Which log? The third log. So that 4 is just going to drop down in front of that third log because it's only on that part. And again, I think the parentheses are important because you have to make sure you're subtracting that whole second half. So it'll be 4 times the log base b of w. Great. Okay. So being able to expand and contract as needed, they might just say rewrite. Again, it might not seem necessary to do this, but there's going to be times that things will cancel when we break them up like that, and it works nicely. Sometimes things will be good when we do those. So these next couple kind of refer us back to our lesson from last time, that if I'm taking the log and the base matches the number I'm taking the log of, things can cancel. But if you look at this one, log base 2 of 8 to the second, nothing can cancel because the 2 and the 8 don't match. So any thoughts on what we could do to fix that? You're going to drop down the 2? Yep, so let's drop down the 2, and that's fine. There are other ways to do this one, but that works just fine. So let's drop that down in front. It's 2 times log base 2 of 8. Okay. Can we do anything with this? Kind of goes back to what I did over here. So I rewrote 9 as 3 to the 2nd because that was helpful to me. Can I rewrite 8 in a way that would be helpful to me for this type of problem? Can 8 be written in a different way, maybe using exponents that might be helpful? Yeah. Oh, what's it? No, it's okay.
2 to the 3rd?
2 to the 3rd power is the same thing as 8. The reason why we chose 2 to the 3rd power is, first of all, 8 can't be written with another exponent of it, like it's 4 to the 2nd 16. So 2 to the 3rd is kind of the only good way to write that. So the reason why we like this is now the base matches what we're taking the log of. So what happens then, or what do you want to do now? Yeah, what do you think, Stone?
Make the log base 2 to the 3rd equal 3.
So yeah, that kind of cancels and becomes like a 3. So like this cancels out. Now that 3 kind of seems like it's kind of hovering up there. So where is it really going to end up?
Place.
It's going to kind of be in place of, but it also ends up in front. So it really becomes, what are we really doing here? What are we? We get 6. We just multiply 3 times 2. Okay, let me show you guys let me show you guys another way to look at this. Because there are multiple ways to get this answer. I just want to show you in case somebody else was thinking this but afraid to speak up because we didn't, somebody else said something first. So I'm going to kind of use the board over here again. Hopefully, sorry those of you online if this is really hard to see, but try to make this work. So I'm going to just show you another method that might work as well. And it's kind of whatever you notice first. So using the 2 to the 3rd power, so essentially what you guys just did. But what do we normally do with the exponents? Power to a power, we do what? Multiply them. So it becomes 2 to the 6th. And we learned last class that this just cancels. So this just equals 6. It's essentially the same thing we just did there. It's just maybe a little more streamlined, or you're not dropping things down in front as much. So that maybe makes more sense. It's the same thing. We got the same answer, same process really, just slight little differences to how I showed it. So whatever one makes the most sense to you, just kind of getting used to rewriting things in a way that's helpful for us. I feel like we could have done this one last time, but maybe, do you guys remember what we can do with that root? That cube root, what happens with that? What's this the same as? Remember? The 1/3 power. So this is really like log base h of h to the 1/3 power. So don't forget that roots and fractional exponents are the same thing. The negative, I heard someone say -3, that's if it was in the denominator. So that's when we have like a fractional exponent. So again, when we take the base and we have the same base as what we're taking, this is just left as 1/3. And if you wanted to drop it down in front, that's fine. It doesn't really matter at that point. It's all that's like left. Okay? All right. Yeah, we'll probably do for a break, huh?
We're going to chase the base.
What's that?
Never mind.
All right. I know I have a video for you guys for